All right, today we're going to be tackling the problem down the toilet. Looking at a company that makes hotel toilets, and they're claiming that their new pressure assisted toilet reduces the average amount of water used when compared to the current model. To test this, they randomly selected 30 toilets of each type and measured the amount of water used when the toilet is flushed. For the current models, they got 1.34 gallons for an average with a standard deviation of 0.28. For the new toilets, they had a mean amount of 1.09, standard deviation of 0.18. We are looking to see if there's enough evidence to prove the new model toilet uses less water. We also want to see what type of error could have been made. Okay, so since they're asking for evidence here, that means we're doing a hypothesis test. Since we're looking at averages from two samples, we're looking at a two-sample t-test. First thing I'm going to do, I'm going to write my null and alternate hypothesis. My null here. Now I'm going to do mu of, let's say, C will be current toilet. And we'll do mu of, let's see, they have a different name for these, pressure assisted. So I'll go with U of PA, pressure assisted. And again, I mean, you can label them whatever you want, really. I'm just doing this to help me keep track. I'm even just going to make that mu of P. Alright, so what am I trying to prove? Well, first of all, our null is always going to be dull, nice and equal. So we're looking at mu of C is going to equal mu of P. Now for my alternate, now actually before I jump to them, I always like to show the second option. You can do mu of C minus mu of P equals 0. Because the truth is, if they're equal, then when you subtract them, you should be getting an answer of 0. Some people like to set their null up like that. You are more than welcome to. I prefer the first option myself. All right, for my alternate, I'm trying to prove that the new toilet uses less. So I'm going to do mu of C, my current toilet, is greater than mu of P. Why? Because if mu of P is using less water, then I'm going to be seeing that the current is going to be using more. So mu of C should be greater than P. Mu of the current, the average of the current should be greater than the average of the new pressure assisted. Now for if I want to go with the second option, it's going to be mu of C minus mu of P. And now if the current toilet is using more, right, when I'm subtracting these two values, I should be getting a number greater than 1. So this is the second option. Again, this is the one I prefer. Just personal preference. Some people like the second option. That's fine. This is the way I'm going here. All right, now you might be inclined to start your hypothesis test, but you have to check your conditions. Truth is, your results might not necessarily be valid if you're not checking your conditions. You got to do that. First thing I'm looking for, is it random? Let's see. A company randomly selects 30 toilets of each type. Awesome. Random. Done. Check that condition. Next thing I want to check is, let's see, we'll go with large sample. And it says 30 of each. So that means 30 is greater than or equal to 30. Works. 30 is greater than or equal to 30. That works. So that tells me that it's going to be coming from a normal population. I like that, because if you're going to be getting greater than 30, guarantee that's coming from something normal. If it's less, then you have to prove it. All right, now the last one I have to check is my 10%. They don't necessarily give me that information here. That's something that they probably should have, but they didn't. So what we're going to do is we're going to say, for our 10% condition, we're going to assume that 30 is less than or equal to 1/10 of all current toilets. And we'll go with the assumption that 10%, well, actually, I'm not going to write that again, but since they did it for both toilets, we'll say 30. We'll hope that is less than or equal to 10% of all new toilets. Which I think it's fair to say they're probably producing more than 300 of these toilets. So, I guess that's a fair assumption to make here. All right, so we've met our conditions. Remember, you always check those. All right, so now I have to run a hypothesis test. Since I'm doing two samples here, current and pressure-assisted toilets. It's, two samples. I'm looking at averages. So that's T. I'm looking at T here. So pull it up on the calculator. After last time, I actually did it out first to make sure it works. Okay, so I'm going to go to two-sample t-test. Go to stats. Oh, and I have to enter it all in again. That's okay, it's good practice. Alright, so my standard deviation, I find I have to enter this in first. Kind of a program flaw. And then I'm looking for the average 1.34. Based on a sample size of 30. My other one was 1.09. Standard deviation of 0.18. Sample size of, again, 30. Now, what am I trying to prove here? I'm trying to prove that that second average, or that second sample is going to, or second population is less than the first one. So I'm going that mu1 is greater than mu2. That's the option I'm going with here. Pooled, don't want to pool your data. Don't want to do that, at least at this level of statistics. So then we're just going to do calculate. And I get everything I need to here, which is great. So I'm going to scroll down here. I'm going to write down all the necessary information. To sample t-test. Say what you did. Write down your test statistic. T equals 4.01. That's good enough. And then p-value. Be mindful of something here. What I've noticed is a common mistake is that a lot of times they give you the answer in scientific notation. If it's really low, people have been seeing answers like 8 times 10 to the negative 8th, and they see the 8 and they say, oh, that's greater than 0.05, my significance level. No, it's not. You gotta pay attention to scientific notation. If you're looking at a p-value and your p-value is greater than 1, then you did something wrong or you're reading it wrong. So alarm bells need to go off. You should not be getting a p-value of like 2, 3, 4, heck, even 1.06, something like that. That's too much. P-values aren't meant to be greater than 1. If you did that, you did something wrong or you're not reading it correctly. Go back and check. All right. You know, I'm going to put down degrees of freedom too. Good thing to keep down here. You'll notice that it's a decimal form here. Your calculator calculates the degrees of freedom. It's a bit tricky to do by hand, so that's why we let our calculator do a lot of the work here. Alright, so I got a p-value that's pretty darn low. So since it is definitely less than my significance level of 0.05, I can reject my null hypothesis, which tells me that the averages are the same for the new toilets and the old toilets. What I've proven here is my alternate that the current toilets consume more than the new toilets. All right, so I'm going to write my null. I'm going to write my conclusion. Since p-value is less than significance level, I have enough evidence to reject the null. I know this takes a little bit of time, but you always want to write this out in context. That's what it's about. It's not just about numbers and statistics. It's about context. So I have enough evidence to prove the current toilets use more water than the new toilets. All right, cool. And we're done here. So again, just to do a quick recap. I need evidence here. If I need evidence, that means I'm doing a hypothesis test. I'm going to try and get rid of that. Cool. So they're asking me for evidence, hypothesis test. I have 2 averages that I'm comparing. That means it's going to be a 2-sample t-test. Check my conditions, large sample, 10%, and random. Set up my null and my alternate here. Null is dull, always equal. And my alternate here, I wasn't just trying to prove they were different. I was trying to prove one was greater than the other. And I ran a 2-sample t-test. These are the values I got. And since my p-value was less, I had enough to reject my null hypothesis. Hopefully this helps.